Okay, so hey everyone. Today I'll be recording a probability practice for the IGCSE periodic that we have on Tuesday. I made a document with 7 questions, four of them from IGCSE past papers, and I put the code for them if you want to go to the actual past paper itself. Just copy this and paste it on Chrome, and 3 of them are from ChatGPT. Now, the marking scheme is after the last question. And at the end, at the last page, there is a formula sheet with all or most of the probability probability questions that are needed in the actual periodic. Okay, so I'll start with question 1. Tanya plants some seeds. The probability that the seed will produce flowers is 0.8. When a seed produces flowers, the probability that the flowers are red is 0.6, and the probability that the flowers are yellow is 0.3. Now, 0. So Tanya has a seed that produces flowers. Find the probability that the flowers are not red and not yellow. So let me just get the open board. Open board. There we go. Okay. So the first question, it says that it wants us to find the probability that the flowers are not red and not yellow. If you notice here that it's not the probability that it produces a red flower is 0.6 and the probability that it produces a yellow flower is 0.3. So the probability that it's not red and not yellow is the 1 minus the probability that it is red or that it is yellow. So to find that, you just add up 0.6 and 0.3, which is 0.9. 1 minus 0.9 is 0.1. Okay. Question A, no, question B, part I. Complete a tree diagram. Okay. So, it's a seed. The seed can produce flowers, F, or no flowers, NF. Now, the probability that it produces flowers, that's a W. I'll just erase that. Okay. The probability that it produces flowers is 0.8. So, I'll just write 0.8. And the probability that it doesn't produce flowers is 0.2. Now, it says that it can produce not three colors, but it can produce either red or yellow, or other colors, because there's a 0.9% chance or 0.9 probability that it produces red or yellow if it produces flowers. There's a 0.1 that you have to account for. So 0.1 is it produces another color. So I'll just write O for other, red or for red, and the Y for yellow. Okay, the probability that it produces red is 0.6, and the probability that it produces yellow is 0.3. So the probability that it produces other colors is 0.1. Okay, uh, that's part B for first question, part B. So double I. Find the probability that the seed chosen produces red flowers. So now you just follow your tree diagram. So probability of S for seeds, red flowers. So FR equals 0.8 because the probability of it producing a seed is 0.8 multiplied by 0.26. Sorry, because again, if it produces red flowers, there's a 0.6 probability of it doing it. 0.6, 0.8 times 0.6 is going to be 0.48. That's our answer. Now, Tanya chooses a seed at random. Find the probability that this seed does not produce flowers, does not produce red flowers, and does not produce yellow flowers. So there could be 2 cases for this one. It's either doesn't produce seeds, that seeds doesn't produce flowers at all, or it produces a flower of another color. So B S for seed, F not red, or F not yellow equals to P S no flowers plus probability of a seed that produces a flower of another color. So FO. Okay. So now, P, this the seed doesn't produce flowers. We have it from the probability tree. It equals to 0.2. So P, S, and F equals to 0.2. Now, the probability of it's producing a flower of another color is P. Let me just call it P S of 0 is equal to the probability that it produces that the seed produces a flower. So 0.8 or 0.8 multiplied by 0.1. 0.8 multiplied by 0.1 is 0.01. Again, calculators are a lot, but يعني this is simple mental math. So you add them. PS, I'll just bring this over here because I don't want to write it all again. Equals to 0.2 plus 0.08, which equals, I'm sorry, that's it. 0.08, which equals to 0.28. Okay. Part C, two of the seeds are chosen at random. Find the probability that one produces flowers and one does not produce flowers. There's two outcomes. Yani one, that the first seed produces flowers, so SPF, and the second seed does not produce flowers, SNPF. Or you can have the seed does not produce flowers, and the seed produces flowers. So this expands, these two will make up the probability of a seed that one of them produces flowers and one doesn't. You'd write that down. P of seed produces one flowers, one doesn't. But يعني it's gonna take a while to write it down on a computer. So I'm just gonna not write it at all. I just said it orally. To find the probability of this, that one produces flowers and one doesn't, you add these two together. So now you find the probability of this, which is SPF. SPF was 0.8 because the seed produces flowers, multiplied by the probability that the seed does not produce flowers, which is 0.2, plus the probability of the seed, the first seed, not producing flowers. So I'm just gonna erase that. Plus the probability of the first seed not producing flowers, so 0.2 times the probability of the second seed producing flowers, which is 0.8. Okay, 0.8 times 0.2 is 0.16. Now again, this one's also 0.16 because it's the same numbers just in a different order. So 0.16 plus 0.16, 0.16 times 2, doesn't matter, equals to 0.32. And that's your answer. Now, if they tell you express it as a percentage, أكيد you multiply it by 100, which is 32%. But they likely won't. Yeah, but you can never know. So maybe they will. Okay, question 2. Canwin plays a board game. Two cubes in brackets dice each have faces numbered 1, 2, 3, 4, 5, 6. In the game, a throw is rolling the two six-sided dice, then adding the numbers on their top faces. This total is the number of spaces to move on this board. For example, if the numbers are 4 and 3, he moves 7 spaces. Okay. Giving each of your answers and as a fraction in the simplest form, find the probability that he moves 2 spaces in this next row. So 2 spaces, you can only have one outcome for each. يعني he can only move one space each throw. That's what they want. So you find 2 spaces. So P 2S equals to P1S plus P1S, or P1S times P1S, sorry. because they're intersecting events. So, um, the probability of finding P1S, so there's gonna be 1 over 6, right? If you roll the dice, you can only get, by moving one space, you can only get 1. You'll only roll once. So 1 over 6 times, again, 1 over 6. So 2 times 1 over 6, which is equal to, or no, sorry. 1 over 6 times 1 over 6, which is 1 over 6 squared. So 2 over, 1 over 36, my bad. And that's our answer. Okay. Part double I. You can also, by the way, you can also take it as pairs, but on the Cambridge marking scheme, it says it to solve it like that. But you can also take it, for example, you can only find one thing, one pair of dice that will roll you two spaces, which is only one, one. So this is 1 over 36. I know there's 36 possible outcomes of two dice. So this is how بصراحة I would solve it in a school exam, in a computer exam, but the Cambridge ranking scheme says otherwise. The Cambridge ranking scheme says do 1 over 6 times 1 over 6. So I'm trying to follow it لأنه the school sometimes they in the probability they might bring past paper materials and they're probably going to follow the past paper marking scheme. So I'm just teaching it to you like this. Now, 10 spaces with his next row. There's gonna be three possible outcomes. Three pairs. You have 5, 5, and 1, 6, and 4, 6, sorry, and 6 and 4. So then, like really quickly, you can do 3 over 36. Like this. بس هيك, we're done. 3 over 36. بس again, Cambridge doesn't want you to do that. لأنه معاكي 3 pairs. The 3 pairs are fine. You do get 1 mark for it. If you scroll down. You get 1 mark for identifying the correct pairs. So you get a mark for identifying 4, 6, 6, 4, and 5, 5, and you can get a mark by answering 1 over 12 as your final answer. But see, you're missing out on this mark, mark 2. So بس هلا likely it's gonna be out of 2 not out of 3. يعني you don't need to do this. ف صراحة if I were you, I would just do this one to identify the correct pairs and get the final answer by doing 3 over 36. But if you want to do it like this, 1 over 36 times 3, it's fine. لأنه بالآخر هي there's 3 correct pairs. So where are we? We're here. Okay. We're done with this question. Question 3. Ravi spins a biased 5-sided spinner, numbered 1 to 5. The probability of each spinner shown on the table. Okay. Find the value of x. You know that probabilities all add up to make 1. So, what we're gonna do, I'm actually gonna copy this because I don't think I have enough space. There we go. Add to page. I don't really care. So 1 over 6 plus 1 over 4 plus 1 over 3 plus 2x all equal to 1. Okay. Now, according to the mark scheme, which is the way they did it is weird. لأنه they said they accept the way I did. لأنه it says or equivalent. OE is or equivalent. So it's fine. But the way they did it, they put x لحال. يعني they took x by itself. So they moved everything to the other side. 2x equals to 1 minus 1 over 6 or minus 1 over 4 minus 1 over 3 or something like that. What did they do with us? 1 over 6 minus 1 over 4 minus 1 over 3. Yeah. Then they divided by 2. So x equals to half of all of this. So I'm just going to bring it down like this. And then what they did, so they solved for this 1 minus 6, 1 minus 1 over 6 minus 1 over 4. Again, this can be done on a calculator. So I'll just do it now with you guys on the screen. Fx, here we go. So I don't know if I can bring this with me. Can I? No, I can't. Okay. You find it with your calculator. So 1 minus 1 over 6 minus 1 over 4 minus 1 over 3. All of this is in brackets multiplied by 1 over 2. Which will give you, one second, which will give you, if my calculator decides to work, divided by 2, which will give you 1 over 8. Okay, so here it's going to be 1 over 8, and here's going to be 1 over 8. So then, now what do they want? They want, let's go back all the way to here. Ravi spins the spinner once. Find the probability that the number is 2 or 3. Okay, so you can have probability of 2 or 3, which means that it's the probability of 2 plus the probability of 3. So P uh, 2 or 3 equals to P of 2 plus P of 3. So now we look for up at the table. The probability of 2 is 1 over 4. So this goes down to 1 over 4 plus this goes down to 1 over 3. Gives you find the LCD, which is going to be 12. So multiply by 3 here, multiply by 3 up as well. I won't do it on both sides. So it's 3 over 12 plus multiply on 4 on both sides for the other fraction, 4 over 12 equals to 7 over 12. So our answer is going to be 7 over 12. Okay, part double I, or part C, sorry. Let me just go down. Part C, double I don't know what happened to I. Oh, it's I is this first one. Find the probability that the number is 2 both times. So it's gonna be probability of 2 and then probability of 2 again. So probability of 2 times is the probability of 2. So P2 2 equals to P of 2 times P of 2. So the probability of 2 is 1 over 4. So it's since it's repeated, so I'm just gonna write 1 over 4 squared, which is equal to 1 over 16. And that is our answer. Okay. Double I, the sum of the numbers is 3. Now for this. Okay, so apparently I just finished recording, but I just looked at the clip كمان و it wasn't recording properly. It was really buggy. So I'm gonna re-record it. I'll start by saying that I think I did this one. I did check the clip. Yeah, I did do this one. So now we move on to double I. Ravi spins the spinner twice. That's what the question gave us. So and they want the sum to be 3. So it can either be 2 then 1 or 1 then 2. So the probability of getting the sum is 3 is the probability of getting the sum of 2 of the probability of landing on 2 then landing on 1, or landing on 1 then landing on 2. So 1 over 4 times 1 over 6 plus 1 over 6 times 1 over 4. Now the 1 over 6 times 1 over 4 is 1 over 24, and 1 over 4 times 1 over 6 is 1 over 24. So it's going to be 1 plus 1 over 24 plus 1 over 24, which is 2 over 24, which is 1 over 12. But I'll leave it as 2 over 24. Okay. D. Let me just go to D. Ravi spins the spinner 72 times. Calculate how many times. For these types of questions, you're gonna take the probability of the event they gave you. So, for example, the event here is number 1, and the however times he rolled the dice, spun a spinner, whatever they told you, how many times multiplied by the probability of the event. So 72 times. What was our probability for 1? 1 over 6, right? Let me just check. 1 over 6, yes. So 72 times 1 over 6, which is going to be 72 over 6, which is going to be 12. So 12 is our answer. Now, question 4. The probability that if it rains tomorrow, I'll just go to the question here. I have it done. previous. We're here. Okay. The probability that trains tomorrow is 5 over 8. If it trains, the probability that Rafael walks to school is 1 over 6. If it doesn't train, the probability that he walks to school is 7 over 10. Now, we draw a tree diagram like this. If it trains 5 over 8, so it doesn't rain 3 over 8. They said if it trains, the probability of him walking is 1 over 6. The probability of him not walking is 5 over 6. If it doesn't train, the probability of him walking is 7 over 10. If it doesn't rain, so the probability of him not walking is 3 over 10. This is our probability tree. Uh, what's the probability that it will rain tomorrow and he walks to school? Rain tomorrow, so 5 over 8 times 1 over, 5 over 8, what was it? My bad, let me just flip. The probability of him raining, if the probability of it raining tomorrow and him walking to school 5 over 8 times 1 over 6 over 6, which this gives 5 over 48 because 5 over 8 times 6, which is 48. So 5 over 48 is our answer for part B. Part C, what's the probability that Rafael doesn't walk to school? If he doesn't walk to school, that means it either doesn't rain and he doesn't walk, or it rains and he doesn't walk. So 5 over 8 times 5 over 6, which is gonna be, I'll just do it right here, 5 over 8 times 5 over 6 plus 3 over 8 times 3 over 10. So 5 over 8 times 5 over 6. We do this on a calculator. I know it's going to take too long. It's going to be 19 over 30. That's our answer. So that's the IGCSE questions done. Now, in a school, 50, I'll just go to the thing here. In a school, 60% of students are girls and the rest are boys. 30% of the girls play tennis and 50% of the boys play tennis. A student selected at random. Find the probability that the student is selected as a girl that who plays tennis. Now, this means that it's a girl that plays tennis. So it's a girl that plays tennis. They're both happening at the same time. So it's G intersection T. Why I say it like in this form, you're going to need it for part C. Is equal to 0.6 because 0.6 of students are girls and 0.4 are boys. So 0.6 times 30% play tennis, so that's 0.3. 0.6 times 0.3, 0.18. If they ask what percentage, it's going to be 18%. Now, the probability of it being a tennis player. Uh, which means it's the probability of it of the girl of it being it's a girl that's a tennis player or a boy that's a tennis player. We found the probability of it being a girl that's a tennis player, which is 0.18. Now we find the probability of it being a boy that's a tennis player. So 0.14, 0.4, sorry, are boys, and 50% of them, so 0.5, 50% is 0.5, akid. So 0.18 plus, that's a plus 0.4 times 0.5. 0.4 times 0.5 is 0.2. So 0.18 plus 0.2 is going to be 0.38. So that's a 38 or 38%. That's part B. Now, part C. Given that the student selected plays tennis, find the probability that the student is a girl. For this, you're gonna need to know the conditional probability formula. You want to find a probability A, so probability you want to find probability A. Probability A is unknown given probability B. So probability of A given probability B is equal to the probability of A intersection B divided by the probability of B. You just memorize this. If you want A given B, you apply this. A intersection B over B. If you want probability of B given A, for example, probability of B intersection A over probability of A, like that. Okay, so we just applied probability of girl given that the student plays tennis. See, given that the student selected plays tennis, find the probability that's a girl. So probability of girl given tennis equals to, we found the G intersection T again because intersection B we just substituted for G intersection T, which is why I changed it to this form, which was 0.18 over the probability of it being a tennis player. So probability over probability of B is T in this case, which is 0.38. So it's going to be 0.18 over 0.38, which is 0.47. Yes, that's a 4. Let me erase it. So 0.47. Okay. Question 6. A bag contains 3 red balls, 5 blue balls, and 4 green balls. 2 balls are drawn at random from the bag, one after another without replacement. Find the probability that both balls are of the same color. Okay. That both balls, I'll just say PSC is equal to P. Uh, first ball was red, and the second ball was red, so P or R. Second, then plus the probability of it being the first ball drawn was B. Then the second ball was also blue, so BB. Plus again GG. I'm not gonna explain why for the third time. Plus GG. Okay. So PRR, 3/12 initially when he drew the first ball, times 2/11, plus 5/12 because 5 blue balls initially over 12 total balls, times 4/11 since you know the new total is 11 and he drew one ball out, plus uh, 4/12 times 3/11. Okay, multiply all of these, then add them. You're gonna get 19/66. Okay, now that's our answer for part A. Now, the second ball drawn was red, given that the first drawn ball was blue. Okay, so there's 12 total balls, right? You took one out and it was blue, so 12 minus 1, 11 total. Now, the red ball, the number of red balls wasn't affected, so it stayed 3. So 3/11. 3/11 is your answer. Okay. Now, the two balls drawn are different colors. So the two balls drawn are different colors. That now, if it's different colors, that's the complement of them being the same color, right? So what you're gonna do is P of DC for different color is equal to 1 minus P of DC complement, which is 1 minus P of the same color. Now we found the probability of them being the same color, which is 19/66. So 1 minus 19/66. Again, this was found in part A. So 1 minus 19/66, which is 47/66. That's our answer. Okay. Question 7, which is the last question. In a class of 30 students, 12 students study math. Event A, 12 students study science. Event B, 6 students study both math and science. What's the probability of a random student? Okay, blah, blah, blah. 1. For this one, you're gonna need to know the union of probabilities formula, which is I helped you out here by giving you event A and event B, like denoting them, because some people don't understand this formula, so I'm gonna simplify it. So P, we want union, so A union B equals the probability of A plus the probability of B minus the probability of A intersection B. So A intersection B. Now, let me just check because I don't want to waste my time. Let me just check if my audio is recording. Yes, we are. Beautiful. Okay. Here. So this is why I denoted A and B. So you can just apply it like this. Now, the probability of A union B. What does a union mean? Because some people don't even know what A and union and intersection mean. Union means that this event happened or this event happened. Like they could both have either happen. Now, A intersection B means that they both happened. This happened and this happened. So, probability of A is 18/30 because 30 students total, and we have 18 of them will study math. 18/30 plus 12/30 and minus the probability of students that study both math and science, which is 6. 6 students, so 6/30. 18 plus 12 is 30. 30 minus 6 is 24. So 24/30. That's our answer for part 1. Now on to part 2. Okay, what's the probability that a randomly selected student only studies math? Now, for this one, I'll call it P of M for mathematics. P of M is equal to P of A minus P of A intersection B. A intersection B. Okay, so what this means, what this is telling me, that the probability of students who study math is that study only math is the probability of students who study math minus the probability of students who study math in general. So this includes the students who study math and science, P of A, minus the students who study both of them, because you want to filter out the students who only study math. يعني انت you want students who only study math, you don't want students who study math and science. Event A, which is students who study math, this includes this. This is part of this, like you know what I mean. So in order to clear this part out, we only want the students who only study math. We don't want people who study science. So we're gonna do this formula: P of M is equal to P of A, which is 18 over 30 minus 6 over 30 which is equal to 12 over 30, which is 2 over 5. 2 over 5 is our answer. That's the end of the document. The under it is going to be the marking schemes, as I said, and the last page is going to be a formula sheet with everything I said. So, good luck, guys. If you have any other questions about probability, feel free to comment. I will answer. Or Hala. Good luck.